said it the other place, it doesn't make it sustainable. You can't run your business. Is it controllable? Can I make sure that it can operate on board the ship under the supervision of the engineers? Is it serviceable? If anything goes wrong with it, can I handle it on board the ship? I have to stop the ship as a minimum of maneuver. Is it repairable? Can I repair the ship? Can I get the spare part that I want? Supportable. Whether the people who sold it to me are able to come and help me to operate it, to repair it, or to support it. Can it be monitored? Can I monitor operational parameters which are required to operate that particular system on board my ship? Is it durable? Does it last on board an ocean-going vessel? Is it going to take all the pressures, all the vibration, all the heat? Is it reliable? How often is it going to go faulty? And how often I have to stop unloading and loading my cargo because my ballast water system is not working? Do I need redundancy? If the system cannot be operated at some point, do I need additional parallel system like the other systems on board the ship? Is it robust enough to be able to take different type of water and different type of environments and different type of species? Can it be easily operated? Just press of a button, press of the other button. Does it make life difficult for the people on board the ship? Is it going to have radioactive radiation, or does it have a huge temperature difference between the system and the other pipes? Does it make life difficult for the engineers on board the ship? Is it compatible with the other system in terms of the voltage, in terms of the area which is going to be installed? It's going to damage the other system which is next to it just because it operates at a different operational condition. Is it affordable? Affordable goes for capital cost and operational cost. Is it cheap enough or is it expensive? Is it environmentally friendly? Is it going to cause more damage to the environment before it's going to solve the other problem? Is it going to produce chemicals to the water? Is it going to radioactivate the water, which is going to be again harmful to the environment? Is it safe to operate? Classification societies are going to look into that in particular. Does it fit the mission profile of that particular ship or a large fleet of ships? So this is another important factor, whether the system which is going to be installed on board that ship. And finally, does that meet D2? We started with D2G8, we're going to end up with D2G2. G2 is the part of the convention which talks about when the ship arrives in your port, whether it has complied with the IMO regulation or not. So you go on board the ship and take a sample of the water, and whether that sample meets the IMO criteria or not. So we start with the design, which is G2, and then we end up with D2G8, and we end up with D2G2, which means end of the operation. Whether the systems have reached that point or that target, reaching that target, this means absolute sustainability. It's difficult to get there. You have to go round and round of design. Similar to the ship design. You have to go probably many, many times around that circle to get the final solution and to get the best solution. And there have been some designs which could fall into that category, or over there, or over there. Have we hit the target yet? No. So none of the solutions at the moment meets the sustainability criteria. Well, it doesn't matter, as long as we are close to that target, we are in the right path. This is the end of this story. You might say, yeah, you told me make it sustainable. Yes, I went through all that circle. Yes, I met all the criteria. But is it the end of this story? No. Marine industry in particular is facing a challenge every day. We have credit crunch one day, and we have the other issues with regulation, with the anti-fouling and incompatibility of the anti-fouling with the other previous resolutions at IMO, and a lot of issues are coming as we go forward. And is life going to get easier? No. You ask an engineer who was operating your ship 20 years ago, I was the one. It was a lot easier. You just used to go to the engine room and do a few operations and come off and then watch TV. Now engineers don't have time even to scratch their head. So this is the issue. Do we have to be ready for the new challenges, and whether our solutions are going to meet the new challenges or not? These are the new challenges. Whether there is an agreement between India and Bangladesh that I'm not going to inspect your ships, you don't inspect my ships. Because now everything is related to the territorial waters. And every government has to make that decision. Who's going to monitor and who's going to do the risk analysis? And who's going to give exemptions to whom? In India, if you take water from the Bengal side and take it to the Bombay side, it is considered illegal. Scientifically, but legally, you can do it. Because you're in the same country's jurisdiction. In the UK, if you take water from Inverness and drop it at Southampton, you are legally correct. But scientifically, you're introducing a species which they do not belong to Southampton or to the south of England or south of any part of the UK. So this is one issue that who's going to take over that one, because IMO doesn't care. China is a vast country, the east of China and west of China, or north of China, south of China, similar to Russia. They are the same countries, but they are not going to have the same quality of water. And enforceability is an issue, and Bangladesh is going to come to that one. If the regulation is ratified, who's going to take the samples, who's going to take representative sampling, and who's going to arrest the ships? And the ships that you're building in Bangladesh, do they comply with those regulations? If they go under this sampling and enforceability, do they come out successful or not? It's extremely important. If they don't, they can't go to those territorial waters. It's as simple as that. The ship will be designed perfectly, but if you do not have the right treatment system, you are not allowed legally to enter certain countries' territorial water. And this comes to enforceability issue. These are our immediate challenges that, again, engineers and designers have to look at that. So if you do not meet these two, again, your system is not sustainable. So what I missed in the previous ring of sustainability was political and legal issues that you have to take into account. It doesn't make any sense if you design something and the government says you can't sell it. Your system is not sustainable. And the ultimate challenge in the change of environment recently in Newcastle, this is what I just want to give you a little example of how marine environment and how engineering design are going to be faced with additional challenges, whether we like it or not. And that is why we need education. That is why we need a lot more research at all levels. And this is what we have been doing with our biologists. Recently, we found same species that have been traveling on board the ships. This particular type of species goes back millions of years. We have got samples from bottom of an ice hole in Japan, and they showed that this is the same species. They survive a lot of things. They survive typhoons, they survive high temperature, low temperature, and we want to kill them and to make sure they are not transported between different countries. If they are able to sustain such a history of damages and challenges by we can call it God, that during the years of the Earth they have survived that. Do you think a simple system that I'm going to just expose them to certain UV radiation is going to get rid of them or not? We found that a species in Newcastle. This species never showed any sign of protection during treatment. Historically, it has never shown that sign. But recently, when this species, which is called Petrosalmus, is exposed to certain type of UV and exposed to the high temperature to be killed, it now defends itself. It has divided itself into three groups: soldiers, normal people, and elites. And as soon as it does that, the soldiers start protecting the normal people, and some part of the normal people turn themselves into elites, and elites are reproducers, the ones which are going to survive. This means this species is responding to our treatment. It's exactly like the advice from the doctors say, do not eat too many antibiotics because your bacteria gets resistance to it. This is like a bacteria, and it's getting resistance to the type of treatment you're doing. This means whatever treatment you're doing on board the ships now, in 10 years' time, the species which are live animals, the live trees, the live plankton, they can respond to our treatment. This means the next generation of them, when they come on, they might say, tough, you can't kill me anymore. And this is what has never been seen before. We just noticed it about 2 months ago. Whether this species is going to turn into a beast, this particular one has started or not, but this is our challenge as engineers and scientists to make sure that we design our systems in a way that it can go on and could be still operational in the next 10 years. At the end of the day, we have to design systems which makes us good ancestors and in the next decades to come. Thank you.
Thank you, Professor Zbani.